All right, so now this brings us to Newton's third law of motion, and this is one of his more well-known laws. The law that states that for every action there is an equal and opposite reaction. And this is what you see right here, right? Bart has this fire extinguisher and he's sitting on the chair. And when he pulls that fire extinguisher, the material, the substance like shoots out one way, but he is propelled the other way, right? So it shoots out one way, he goes the other way. Same thing with the rocket that we saw earlier, right? The rocket explodes, the explosion goes downwards towards the earth, but that propels the rocket up towards the sky, right? So an equal opposite for every action, there's an equal and opposite reaction. So there's an equal force acting in the opposite direction of objects, right? Like right now, gravity is pulling you down into your seat. But Newton's third law says your seat is pushing up against you with equal force. And so this is why you're not moving, right? There's a balanced force, like we talked about with that book. The gravity pushing down on the book, the table pushing up on the book, right? So it's not going anywhere. It's balance. But gravity pulling you down, your seat pushing you up. But look what happens right here in this GIF. The student gets his chair pulled out from under him, and he's no longer sitting still. Right now, he's falling on his butt and rolling backwards because there's no longer that balanced force. But think about this. Think of the example of a skateboarder, right? What happens if you're standing on a skateboard or a slippery floor and you push against a wall? You push forward and then you get pushed backward. Same thing with this person in the GIF right here, right? They're kicking their foot backward, but the skateboard is going forward. You slide in the opposite direction away from the wall or away from where you're kicking because you push on the wall, or in this case of the skateboarder, they're pushing on the ground forward, but the wall or the ground is pushing it in the equal and opposite direction, right? With equal and opposite force. So again, kick back on the skateboard, you get propelled forward on the skateboard. Another example is this, and unfortunately, some of us know this all too well, right? Why does it hurt so much when you stub your toe? When your toe exerts a force on a table, the table is going to exert an equal force back on your toe. And then the harder you hit your toe against it, the more force the table exerts back on your toe, and it's going to hurt, right? It's going to hurt a lot. And so, same thing with a frog, right? If you think about a frog swimming in water, it pedals like it pushes his feet backwards, but the frog is propelled forward. A bird in the sky, right? A bird pushes its wings downward, but the bird is propelled upward, right? There's a lot of examples of this, but this is what for every action there is an equal and opposite reaction means, right? So don't make sure that you're able to explain this in your own words. And don't be surprised if you see these on the final exam, right? His three laws of motion. So just remember, his first law, objects in motion tend to stay in motion and objects at rest tend to stay at rest unless acted upon by an unbalanced force. Second law, force equals mass times acceleration, right? F equals force, M is mass, A is acceleration. Newton's third law is for every action, there is an equal and opposite reaction. And just remember these terms. Inertia is a tendency of an object to resist changes in its motion. Basically, an object at rest stays at rest. An object in motion tends to stay in motion, unless they're acted upon by an unbalanced force. Acceleration is just a change in velocity. It's just a measurement of how quickly an object is changing speed, direction, or both. And then velocity is just how fast something moves and in what direction. And then force is strength or energy.